What is a doubly linked list? Give some examples. It is a complex type, double-ended LL, of a linked list in which a node has two links, one that connects to the next node in the sequence and another that connects to the previous node. This allows traversal across the data elements in both directions. Examples include a music playlist with next and previous navigation buttons, the browser cache with back-forward visited pages, the undo and redo functionality on a browser, where you can reverse the node to get to the previous page. 12. How do you reference all of the elements in a one-dimension array? Using an indexed loop, we may access all of the elements in a one-dimensional array. The counter counts down from 0 to the maximum array size, n-1. The loop counter is used as the array subscript to refer to all items of the one-dimensional array in succession. 13. What are dynamic data structures? Name a few. They are collections of data in memory that expand and contract to grow or shrink in size as a program runs. This enables the programmer to control exactly how much memory is to be utilized. Examples are the dynamic array, linked list, stack, queue, and heap. Enroll today for the Java certification training course to learn all about arrays, loops, operators, and more. Check out the course curriculum now. 14. What is an algorithm? An algorithm is a step-by-step method of solving a problem or manipulating data. It defines a set of instructions to be executed in a certain order to get the desired output. 15. Why do we need to do an algorithm analysis? A problem can be solved in more than one way using several solution algorithms. Algorithm analysis provides an estimation of the required resources of an algorithm to solve a specific computational problem. The amount of time and space resources required to execute is also determined. The time complexity of an algorithm quantifies the amount of time taken for an algorithm to run as a function of the length of the input. The space complexity quantifies the amount of space or memory taken by an algorithm to run as a function of the length of the input. Become a data scientist with hands-on training, Data Scientist Master's Program Explore program. 16. What is a stack? A stack is an abstract data type that specifies a linear data structure, as in a real physical stack or piles where you can only take the top item off the stack in order to remove things. Thus, insertion, push, and deletion, pop, of items take place only at one end called top of the stack, with a particular order, LIFO, last in first out, or FILO, first and last out. 17. Where are stacks used? Expression, evaluation, or conversion of evaluating prefix, postfix, and infix expressions. Syntax parsing. String reversal. Parenthesis checking. Backtracking. 18. What are the operations that can be performed on a stack? A stack is a linear data structure that operates on the same concept, in that components in a stack are added and deleted only from one end, referred to as the top. As a result, a stack is known as a LIFO, last in first out, data structure because the piece that was put last is the first to be removed. A stack may perform three fundamental operations. Push. The push action inserts a new element into the stack. The new feature is placed at the top of the stack. However, before inserting the value, we must first verify if top equals max 1, since if so, the stack is filled and no more insertions are possible. An overflow message is printed if an attempt is made to put a value into an existing stack. Pop. The pop operation is performed to remove the stack's topmost element. However, before removing the value, we must first verify if top equals null, since if it is, the stack is empty, and no further deletions are permitted. An underflow notice is produced if an attempt is made to erase a value from a stack that is already empty. Peek. A peek action returns the value of the stack's topmost element without removing it from the stack.